Hello and welcome back to Mikey's Flight Deck. Today I will show you how you can build this IRS panel for your Boeing 737 overhead panel. To start the construction, you will need the acrylic bottom and middle plate, the two top plates, two 8 and 12 position rotary switches. These 12 position rotary switches come with a little ring here, and on this ring sits a nose, and with this ring you can reduce the number of positions of the rotary switch. So in this case here, for the upper IRS panel, we have 1, 2, 3, 4, 5 positions here, and I will reduce the upper rotary switch to 5 and the lower switch to 2 positions, so that I can turn it wider than it is needed. And for this, you look out for the number here on the ring. It's not visible on the video, I think. And you bring in the nose to the position 5, like this. And so this switch will block after 5 clicks. Now let's come to the keypad of the IRS panel. I didn't want to have too much cabling in the back. I want to use backlightable buttons that have the LED already built in, and so I will need power for the backlighting, and the best would be I can use the 12-volt power supply that I'm using for the rest of all the other panels. And I will need the ground wiring for all these buttons, and for every button, one cable going to the Arduino. So I didn't want to give up my PCB making tries, and I gave it another try. And this time 2 steps back, not a double-sided PCB, and not all of the connections are on the PCB, only some of them. And I thought what would be the best and the most help connecting these buttons here. And so I thought all the ground connections could be implemented on the PCB. You can see this here. There are 12 buttons, and the ground is shared here on the PCB. And also the ground and the power for the backlighting. I'm using a 12-volt power supply. Every LED here runs with 3 volts, and so I thought it could be possible that I'm bringing 4 of these buttons in a line, and they have one connection to the power supply. I didn't want to go up to the maximum of these LEDs, and so I have built in a 100 ohm resistor to dim this a little bit down. Yeah, and the connections to the Arduino aren't implemented on the PCB, and they are just soldered directly to the buttons. And this is the design I came out with. You can see all the buttons arranged here, and only a little bit of wiring on the PCB here. The hose to hold it for mounting, and the resistors are built in, and a little connection here for ground and power of the 12-volt power supply, and the ground connection to the Arduino. To create now the isolation around these wires, I'm here back in Flightdeck. I have used this before when I have tried to make PCBs on my CNC, and also for my first tries on the laser. All these times I have concentrated on cutting on the edge around of every wire. I came out often with two thin wires here, and I thought I should concentrate more on this isolation process now, and not so much on these wires, but making a good channel around them. By the way, I'm not going here into everything of FlightCam in detail. You can see this in my dedicated PCB making video. It's a long video and it goes through every step of making a PCB here. So let's concentrate here on the isolation of the wires. And for this, I'm selecting the bottom layer here. First of all, I'm inserting my tool diameter. I know the beam of my laser is something around 0.14 millimeters here. And I will make only one pass and create the isolation geometry. So here you can see this in detail. What I have done is creating a path around it with a distance of the half of 0.14 millimeters. So this will be the first side of my isolation. Now I want to create the other side of the isolation, and for this I will create another isolation routing with the bottom layer, and I want these two isolation lines be something like 0.4 millimeters away from each other. So my first tool had the diameter of 0.14 millimeters. Now I want to add 0.4 millimeters to it. Then the second tool must have a diameter of 0.8 plus this 0.14 millimeters. So I will come out with 0.94 millimeters of diameter for the next tool. I generate the isolation geometry, and let's zoom in here. What do we have here? So what we've created now is this second path here, and this channel here is now the isolation channel I was aiming for, and this I want to let engrave the laser later. And this is what I come out with when I have imported it into the control tool for my laser. Not everything is cut out with the laser. I will now cut out the PCB first on my CNC. My laser can't cut through metal plates or a PCB, and then make the engraving with the laser. And only these parts you can see, which are blue here. I have mirrored it before because this side will later be bottom down on this PCB. And when the whole lasering and etching process went well, then I can again drill it on my CNC. So let's hope that everything works like I've planned. Yeah, the engraving came out really nice. The line around these wires is as thick as I hoped it would be, and the wiring connections are much thicker than they were in my first PCB tryouts in my electric panel, which didn't work. So I think if the etching process comes out well, and if later the drilling works too, then this could be a good PCB. Before drilling all the holes, the PCB was cleaned with acetone and put into a thinning bath. So the PCB came out really nice now. I think concentrating on isolating more around the lines than following the lines exactly is what you need, whether you do it on a CNC or on a laser. I can also see that the vertical lines are a little bit thinner than the horizontal lines here. And I think this comes because the laser is going horizontally, and so it has to stop just before and reactivate after the vertical line. And this is a really time critical process, and so there it can be that it goes off a little bit too late or on a little bit too early, and so this can result in a little bit thinner line, but it doesn't matter, it looks good. I think also I can go a little bit more thinner, maybe 1/10 of a millimeter here, so that I can get more space for lines in the future. The drilling is okay, not perfect. The holes on the bottom are really at the point, but when it comes more at the end of the PCB, then they are a little bit out of alignment. Maybe I have to invest in a little bit more precise aligning tool, but this will work too. So I have to place now the components on it and then hopefully soldering it, and it will work at the end. Beside a fully resin printed button cap, I designed one that is splitted into a lower part of clear resin and a top part of acrylic. These two parts are glued together. Now all these black painted buttons have to be engraved. Maybe you remember the video where I built my first EFIS panel. I had to engrave every button of these separately on my CNC. This time I want to be a little bit more efficient, and for this purpose I will use my laser here, and I will cut out all the openings for the buttons like they will be on the panel later, but a little bit wider, so that these black buttons will slide easily into here. And I will make sure that the plate with these cutouts can't be moved after the cutout, so that I have this plate and all the holes aligned here to the laser. Then I will insert all the buttons here and engrave them all in one step. I haven't done any tests so far with engraving resin printed buttons. I hope that I can use the same settings on the laser like I do when I engrave acrylic. We will see what comes out better at the end. I know the question that the critical viewer might have now at this moment. Why the hell aren't you just taking a black painted sheet of acrylic and engraving and cutting them out in one step? Idiot! Yeah, that's a point. But let me explain my choice here for this method. If I would cut out the buttons from a black painted sheet of acrylic, then I would come out with a white border around it. I have painted them black, I think on my last video with a pen, but for me I think this isn't the same look like a lacquered button. And so with this method I'm using, I have a little bit more work to do, but the button is all over covered with the same structure of paint. Yes, and it looks like one solid piece. And so this was the reason for me that I have chosen this little bit more complicated method. The engraving came out really nice, and even on the resin printed knobs I wouldn't have supposed that this would come out so nice. You can see it here in detail. On the left you have the acrylic knob and on the right you have the resin printed knob, and you can't see any difference. So now a coat of clear varnish onto all the knobs, and then they can be mounted onto the buttons. To not overload this top panel part here with hose and screws, which are not there in the original panel, I have placed some hose underneath here, and I will describe this now to you. These 4 hoses will hold the display, which we will install later here, and it also helps to keep this stack of acrylic together. The same reason for these 2 screws, this will press the 3 layers together here. Underneath, I have placed 6 countersunk holes here where I can insert screws which aren't visible later at the top panel here. And these screws will hold this plate for the backlighting panel of the left side of this panel here and the PCB that we have made before. To mount the backlighting panel, I used 15mm hex standoffs. You will need 7 orange and 2 white annunciators. All the components receive a shared ground connection. To show the line with the coordinates, I'm not using 7-segment displays because it could be very difficult to visualize the letters north, east, south, west with just 7-segment displays. There are more complex versions of this, but this would require a more complex PCB or cabling in the backside. So instead of this, I am using this 16-digit single line LCD display. I have seen ProSim is giving me back 17 digits for these coordinates. On my reference picture that I'm always using, there are only 16 digits visible. I have seen other cockpit builders using these displays, so I think this will be enough for my purpose. You can't use this display alone. You will need a controller, I will call this here, to make it usable together with the Arduino. This controller can be soldered in here at the back of the display, and then you have 4 pins here: power, ground, and the SDA and SCL line of your Arduino Mega. I also changed the angled pin connectors to straight ones. There are approximately 5 millimeters of space between the upper part of the PCB of the display and the lower panel. My screws weren't long enough to go through the stack of all 3 acrylic sheets across this distance through the PCB, and then can be tightened with a nut behind this PCB. And so I have designed and 3D printed these spaces here. They have a length of 5 millimeters. I've cut a thread into them so I can screw into them, and they go just through the hose of the PCB, and then they will hold the PCB in place, and the screw can be screwed in here, and so the display will stay in place behind the smoked acrylic glass. Because I don't implement any brightness adjustment into my panel, I'm not in need of a separate knob for this. And so I have glued these 2 pieces together and just use a single rotary switch. You can download this file with this knob split up into 2 separate units, so you can implement the brightness control if you need it. Now let's come to the last steps here, the configuration in ProSim and MobiFlight. There are some values to configure here when you want to control this via the FSUIPC offsets. In ProSim, you can find them here in the Config and Configuration tab, and you go to Combine Config, because most of the configuration parameters are hidden here in the navigation menu, and you can see there are over 400 items here. You should use again the search function, just search for IRS, and then you can see it reduces to 46. And here you can find the switches you can configure. There I have already entered the FSUIPC offsets I'm using here. And down here you can also find all the indicators that we are using. And you can find the numerical values here. And I will come to these a little bit later. Just the GPS annunciator has to be searched in another menu. You just search for a GPS, and then you can find it here in the Michelangelo category under indicators. There you will find it to configure. in MobiFlight, I have added all the devices to my Arduino I. You can see this here on the extra settings, and in the MobiFlight modules tab here, there you can see I have only connected my Arduino I at this time. And here are all the devices, the LEDs and switches I'm using for this panel here. Just for all the new viewers here on the channel, if you want to know exactly how to add devices and make configurations in MobiFlight, then watch my dedicated video about this. I'm going through all these steps in detail. Just in short, I have added here the inputs, so all these switches here and the buttons, and in the output tab you can find the configurations for the LEDs and the LCD display, and I will come to the LCD display a little bit later. Now let's test all the buttons and LEDs here, and I have opened ProSim Display here for better comparison. I have running prepared in the background and already hit run here in the MobiFlight program. And when I now move these switches here, you can see the switch in the displays tab moves like the hardware switch. Same for the other switch here. Now let's test the annunciators. You can see two of them are already lighted up. Let's push to all of the other ones to see if they are working. The align button here. Fault is working. Desave fail. These are all the left annunciators and the right ones. Here comes the align. On DC, fault and DC fail. All annunciators are working. Now to the buttons. Let's see if this PCB is working, because the press onto a button isn't visualized here in the displays tab. So we change over to the system of ProSim, and we are looking in the navigation tab for the IRS keypad. There we have it. You can see the buttons 0 up to 9 and the two function buttons here. And we go through them. You can see up here keypad 0, it stands on off. And when I press 0, it changes to pushed and off again. And so we go through all of the other buttons, beginning from 1, working, 2, works, 3, works, working, 5 is working, 6, there it is, 7, and the 8, 9 is working, enter, it's working, and clear here is working. Yes, all the buttons are working as they should. And now here to the system display button, it stands on left. There's the right mode and left again. And we change the select knob down to test. Yes, and all the lights are going on and off again. TK mode, position, wind, yes, and heading is working. Back to position mode. So all the switches and LEDs are working. Let's come now to a difficult chapter, the configuration for the display. You may have seen in the live camera that my display is already working. I have done the configuration already, and when I go to this PPOS mode, then all the numbers are shown correctly, but not at all the other modes here. And why this isn't done already, this I will tell you now. You will understand this now when I'm finished with my lecture about this programming here. Let's have a detailed look to this display. It is split into 4 parts. we have the left character here, which is north, N, or S for south. Then we have the left number, which is made out of 5 digits. Then here comes the right character, which is W for west and E for east. And the right number, which is made out of 6 numbers. And when we are looking here to the MobiFlight configuration, you can find these values already. Here we have the IRS left character, the right character, the left number, and the right number. These 4 configurations are only made to bring out the final numbers as I need them here on the display. Let's start with the left character here. You can see the value that comes from the simulator is a 2, and the output is given as an S, which you can see here in the display. So how is this made? We're getting the different characters for the left character here as numbers. North is a 1 and south is the 2. You can see this, we have a 2 here. I have defined an offset here and the size of 1 byte. And now in the compare tab, I'm doing all the magic. You can see if the current value is a 1, so then I will give out an N for north. Otherwise, I will set it to an S. And a similar configuration is made for the right character here. Here you can see I have declared another offset, and in the comparison tab, I say if the value is equal to 4, then it is east. Otherwise, it is west, the W. A little bit more complicated is the output of the numbers. You can see here we are getting a negative value here because we are on the south half of the Earth, but we have to give out it as a positive number. So let's see how this is done. First of all, an offset is declared to, and its size is here 4 bytes. To get rid of negative values, I'm doing a transformation here, and you can use the absolute function, which is called here ABS, and then with a $sign, I'm using the value that I'm getting out of the simulator. So I'm getting the absolute value of this number, which is always a positive number. There is a problem when you want to show up the numbers exactly how they are here in the display, which isn't here at the moment, but you have to take this into consideration. And these are leading zeros. You can see this here on the right side. There is a leading 0 here. On the left side, which we are doing here now, there is none at this moment. But when you are going more to the middle of the Earth, then you are meeting leading zeros here too. A number doesn't have a leading 0. So 0, 0, 1 is given me as a 1, and I have to add somehow these zeros. So it isn't possible to make this with a number. We have to go another way. So here we have 5 digits. And on the comparison tab, I'm saying when I have a value that is bigger or equal than 10,000, then I can use this value, because there won't be any leading zeros here. But then comes the complicated part, and I will show this a little bit bigger to you here. So here we are. This line up here is the same line that I have entered here in the else condition. To see it in a little bit more structured way, I have written it down here so we can go through this better. If our value is bigger or equal than 1000, then we will need a leading 0, which we will add in front of our value here as a string, which you can declare with these signs here. So up here in the display, you can see up here in the display, 1000 would be 4 digits. So we will need up here a leading 0. If we are only bigger or equal than 100, which are these 3 digits here, then we will need 2 leading zeros, these 2 numbers in front of here. And you will guess it, when we are bigger or equal than 10, we will need 3 leading zeros, and otherwise we'll need 4 leading zeros. That's all the magic about these leading zeros here. Let's have a look at the right number now. There is nothing that will surprise you now. You can see the formula here a little bit better. The only difference is that the first current value that is compared here is 100,000, because here we have 6 digits instead of 5 on the left side. And so all the other steps are a little bit bigger. We start here with 10,000. But this is all the difference to the first configuration. But none of the configuration we have seen until now is responsible to show up the value on our display. This is the task of this configuration here, the IRS PPOS configuration. You can see the type here, LCD display, which informs you that this configuration will give out something to the LCD display. When we are looking into this configuration, then it doesn't need an own offset. This is just an offset which is used from a configuration before, but it doesn't matter for this configuration here. It uses other configurations which are marked here. You can choose a configuration out of this drop-down box here, and don't forget to check the use box here. All these configurations can be assigned now with a character here. You should write down these characters, and so you don't have to jump always to this side and look up which character stands for which configuration. And then on the display tab, I have entered here the LCD display, so that I have chosen my display for an output. And down here in this display, you can enter all these characters. Yes, you can write there. I think it's not self-explaining that you can write into this display here, but you can. And here you can see I'm using the sign for the configuration of the left character first. Then there are the 5 letters with special signs between them. The character down here for the right character, and then 6 times the character for the right number with some special signs between them. And this is the place where all the results of our 4 different configurations are merged together to one line in our display. But why did I choose the method to create a separate configuration for the output? So let's turn the select knob. When I turn this to TK, for example, you can see we have completely different numbers. The same when we go to wind or heading. The signs, for example, here a point, here is no point, and here are also other signs needed, a complete different structure. I have invested now much time to give out the numbers with the leading zeros, which I explained to you. But these leading zeros aren't needed here in this configuration. There are other structures needed. And so this output is only needed when this switch here is in the PPOS position. But how do I know that I'm in the P position? How does this configuration knows in which position is this switch here? We don't have access to the input values directly from here. We have to declare a so-called observer. And this is what I have done here. I have made an observer configuration. I41 is the name of the configuration for the switch being in the PPOS position. And when we look into the configuration, then I'm using the same offset and mask that I'm also using to declare if the switch is in this position. So I'm just reading out the value again for this switch here. And now in my precondition of the IRS PPOS configuration, I have access to this I-41 observer configuration. And I'm saying this configuration will only be activated if the I-41 observer has a state of 1. So if the switch is in this position. So I think you can imagine what I have to do in the future now. I have to rename these configurations also to PPOS configurations because the left and right number are different numbers when the switch is in another position. And so the needs to these numbers are different. I will call these PPOS here. So they are configured with leading zeros and so on. And I will also do configurations for the other states here of the switch so that I can form the numbers as I need them. And then I will have different IRS configurations, for example, TKGS configuration, which then shows up the values like I need them here. So this was a hard ride through all these configurations. And if you haven't understood everything at once, go back, watch the steps again, and try to experiment a little bit by yourself by making some configurations. I also needed some hours to come out with these configurations I have made here and how I want to go on here with the configuration for this panel. But I think for now, the idea behind this is clear and you now have the knowledge to make your own configurations here for your IRS panel. And here it is finally installed. A great result at the end. Not only that I'm away only one segment from a complete homemade overhead panel, but it also showed me again that it pays off when you don't give up. In this case, making a PCB. The complexity of this PCB is 2 steps back from the first version I tried to make, a double-sided PCB, but I have developed a new workflow for me and it has shown that I can produce such an electronic component at home, and when I keep up working on this topic I can raise the complexity a little bit more again. Again, you will find all the files to make your own IRS panel at home, the cutout files for the acrylic sheets as well as the 3D print files for the knobs and the PCB spacers. So stay tuned for the next and hopefully last video of this overhead series. And if you don't want to miss this episode, then subscribe to my channel to stay informed about any upcoming new video from me. So I hope we'll see you soon back on the flight deck.